Southampton, England, 1899. In the harbor sat a very strange ship. It had a long, slender metal hull, tapering at both ends. It had none of the tall bows or broad decks of a traditional ocean liner. From a distance, it looked more like a submarine or some kind of spaceship that had escaped from a 21st century science fiction novel. But in fact, it was an ocean-going vessel. More precisely, it had once been expected to become the ocean-going vessel of the future. And to make that dream real, its owners poured an astonishing fortune into it. This final version of the cigar ship, the Ross Winans, cost as much as £60,000 to build. In today's money, that is roughly £9 million or about 12 million US dollars. And that was only one ship in the entire project. If we also include the earlier experimental vessels built in the United States, Russia, and France, along with decades of research, testing, and modifications, the total amount of money burned by the cigar ship project becomes almost impossible to calculate. So the question is, after all that money was spent, did this ship go racing across the Atlantic? Did it change world shipping? And why do we see nothing like it on the oceans today? The answer is, this hugely expensive ship of the future spent more than 30 years sitting idle in harbor. During that time, money was still spent maintaining it and repainting it. In the end, it was quietly sold to a shipbreaker in Bristol for just £210. Built for £60,000, sold for £210. It was probably one of the most expensive, most stubborn, and most bizarre engineering experiments of the 19th century. In an age without computer simulation, fluid dynamics software, or even a modern system of ship design, engineers had only one way to test a crazy idea: build it for real, send it into the sea, and let the ocean decide. And its creator, Ross Winans, and his family happened to have two things: a great deal of money and an equally great deal of stubborn confidence. This is today's story, a brief history of cigar ships when rich people decided to fight the laws of physics. The story of the cigar ship begins with a very wealthy family. Ross Winans was not a shipbuilder. His real business was railways. By the mid-19th century, railways were being built at a feverish pace all over the world. Railways were not just a form of transportation, they were a symbol of the industrial age. And the Winans family stood right at the center of that wave. Ross Winans first made his name in Baltimore, where he designed and built steam locomotives, accumulating a huge fortune in the process. But what truly made the Winans family enormously rich was Russia. In the 1840s, Tsar Nicholas I wanted to build a railway linking St. Petersburg and Moscow. It was one of the largest railway projects in the world at the time, stretching about 650 kilometers and connecting Russia's old and new capitals. The Winans family secured major contracts to supply locomotives, carriages, and related equipment. According to some sources, one contract alone in 1850 was worth as much as 10 million US dollars. In the mid-19th century, that was an astonishing sum. By 1851, the Russian factory managed by the Winans brothers had produced 164 locomotives and around 2,500 passenger and freight cars. Some 19th century newspapers even claimed that the Winans brothers later earned $30 million from their Russian railway contracts. That figure may not be entirely verifiable, but it does make one thing clear: the Winans family were transnational industrial magnates of the railway age. And this family had more than just money. They also had a very typical 19th century engineer's confidence. They had seen with their own eyes how railways could transform a continent. They had personally helped lay rails, locomotives, and steam power across an empire. So to them, transportation was not something fixed or permanent. If land transportation could be redefined by railways, then why couldn't ships on the ocean be redefined as well? This is the key to understanding the cigar ship. In the 1850s, old Winans decided to extend his business from land to sea. In his view, traditional ship hulls may have been wrong from the very beginning. The ship of the future should not look like a floating house. It should look like a bullet or a shell traveling through the sea. Old Winans was so confident because he had two things. First, he believed he understood machines. Second, he had enough money. And so the long contest between a wealthy family and the laws of physics began. This was not the story of a poor inventor carrying drawings around in search of investors. It was the story of a 19th century Iron Man deciding to force his engineering instincts onto the ocean. Old Winans believed that traditional ship hulls had one fundamental problem: too much resistance. By the 19th century, steamships no longer depended on sails, but they still had to burn huge amounts of coal. And a large part of that energy was wasted simply pushing water aside and creating waves. To him, this was an inefficient design. If speed was the goal, shouldn't the ideal shape be more like a bullet? Or rather, like a shell that could travel through water? In 1858, the first cigar ship was launched in Baltimore, United States. It barely looked like a ship at all. The entire vessel had a long, spindle-shaped body, tapering at both ends and widest in the middle. From a distance, it looked like a giant cigar floating on the water. That was where the name cigar ship came from. But the most shocking part was not its appearance. It was the way it was propelled. At the time, most steamships had their propellers mounted at the stern. But Winans believed that this arrangement might not be the best one. So he did something very typical of Winans. He decided to reinvent even the position of the propeller. On the earliest cigar ship, the hull was divided into a front and rear section, leaving a ring-shaped gap in the middle. The propeller was installed right there. From the outside, it looked as if someone had sliced a gap right through the middle of the ship. Its power came from steam engines inside the hull. Even today, it remains a remarkably bold design. In tests around 1859, the ship reportedly reached a speed of about 12 miles per hour. That number was not astonishing, but it was certainly not a failure either. This gave old Winans hope. He was eager to prove that perhaps the whole world had been building ships wrong. So he decided to keep investing, keep improving, and keep building larger cigar ships. Over the following decades, he and his family would repeat the same pattern again and again. Discover a problem, spend money to solve it, then discover a new problem and spend even more money. Soon, they would come to understand one thing: the ocean is far more stubborn than the railway. After the first tests, old Winans believed that since the speed had already proven the potential of this shape, the next step was to make it longer, bigger, and stronger. And so the hull of the first cigar ship was stretched again and again. From its original 54.8 meters, it was extended to 59.1 meters, and eventually stretched almost insanely to 71.6 meters. This was a very direct and very common engineering approach. If a small vessel can run, then perhaps a larger one will be more stable. If there isn't enough power, add more power. In fact, many engineering projects grow this way, step by step, from small prototypes into full-sized machines. But the problem was that the cigar ship itself was an extreme shape. As this long, cylindrical hull grew larger and larger, its hidden problems grew larger with it, especially stability. On land, a train has rails to define its direction. It has a fixed roadbed to support its stability. But the sea is not a railway track. The sea is a surface that is always changing. It flows, it rises and falls, and it pushes back against a ship from every direction. From a distance, the cigar ship did look elegant and streamlined, but for an ocean-going vessel, its proportions were highly distorted. Take the final version, the Ross Winans, launched in 1866. It was about 78 meters. even longer than a modern Boeing 737, and yet its widest point was less than 5 meters. Its length-to-width ratio was an extreme 16:1, and that proportion created fatal problems. Traditional hulls have a broader bottom and a distinct keel structure. When waves strike from the side, the hull can generate a righting force, helping the ship return to balance. The cigar ship was different. It was almost like a giant cylinder floating on the sea. That shape helped reduce resistance while moving forward, but it greatly weakened transverse stability. Once it met side waves, the hull could roll violently. During early trials, seasickness among those on board was reportedly almost universal. To improve this flaw, Winans later even installed a 12-ton lead stabilizer inside the vessel to lower its center of gravity. But even this did not fully solve the problem. A ship cannot only think about moving forward, it also has to turn, face beam seas, and maintain its attitude in waves. This was where the cigar ship became truly awkward. This extreme design also greatly reduced usable space. The top deck was as narrow as a country lane, and the interior was cramped as well. As a luxury yacht intended for ocean-going voyages, it offered neither sufficient comfort nor passenger and cargo capacity anywhere close to that of a conventional vessel of similar size. And then there was the ship's most iconic feature, the central ring-shaped propeller, which was also a disaster in its own way. Old Winans originally believed that placing the propeller at the ship's waist would not only prevent the traditional stern propeller from being damaged in shallow water, but also push the hull more evenly. But when this huge metal propeller churned violently through the water, it did not produce the extraordinary speed he had hoped for. Instead, it created enormous extra resistance and threw large amounts of water into the air, leaving the deck in something close to a permanent storm. Even worse, in order to install this propeller, the cigar ship was essentially cut in two. This made strength, sealing, and maintenance extremely difficult. Waves kept acting on the front and rear sections of the hull, forcing the split structure around the propeller to endure complex twisting forces. Early cigar ships even suffered hull deformation. Old Winans gradually realized that what he was facing was no longer a problem with one particular component. The problem was the cigar ship itself. If this had been an ordinary investor, the project would probably have ended as soon as so many problems appeared. But the Winans family were not ordinary investors. Faced with the problems revealed by the cigar ship, their answer was to keep modifying it, and keep building new vessels for testing. In 1861, the American Civil War broke out. Ross Winans was briefly arrested because he was believed to be sympathetic to the South. The development of the cigar ship in America was therefore disrupted. So the Winans family turned their attention to Europe, especially Russia, where they already had a strong business foundation. This time, they proposed an even bolder idea. If it could not become a merchant ship, could it become a warship? Ordinary warships had broadsides, and shells often struck their hulls at nearly perpendicular angles. But the cigar ship was different. It had a rounded outer shell, and a shell hitting such a curved surface might deflect, reducing the damage. Today, this sounds a little like sloped armor on a tank. The Russian side showed interest in this idea and carried out related tests. The results were not exactly a total failure, but they were nowhere near successful enough to change the direction of naval development. Still, the Winans family clearly had no intention of admitting defeat. In 1865, a new cigar ship was built in St. Petersburg. That same year, another cigar ship appeared in Le Havre, France. Every test, every modification meant another round of spending. Through all these modifications, the cigar ship began to undergo an ironic transformation. It looked less and less like the original cigar ship. The central propeller was removed and replaced with more conventional screw propellers. Some versions had a propeller at the stern. Others even had propellers at both the bow and the stern. A project that had once tried to completely redefine the ship was now gradually moving closer to conventional ship design. In 1866, the Winans family launched the largest, most expensive, and most famous vessel in the entire series, the Ross Winans. It was about 256 feet long, displaced nearly 400 tons, and cost as much as £60,000 to build. In today's money, that would be roughly £9 million. By this point, it had become the final gamble. But the awkward part was this. The more the Winans family modified the cigar ship, the more it began to resemble an ordinary vessel. Meanwhile, in the 1860s, conventional steamships were improving rapidly. Screw propeller technology was becoming more mature, iron ships were becoming more reliable, and ocean routes were becoming more stable. In 1865, the Inman Line's City of Paris proved that screw-propelled passenger liners could come close to the speed of paddle steamers on the Atlantic route. In 1866, the giant Great Eastern completed the laying of the transatlantic cable, proving the practical value of conventional iron ships. Compared with the radical cigar ship, conventional vessels were evolving in a much steadier way. Today, if someone proposed an entirely new type of ship, they would not immediately start building a full-sized vessel. First, they would run theoretical calculations: resistance, buoyancy, center of gravity, stability, and structural strength. Then they would run computational fluid dynamics simulations to see how water flows around the hull, where vortices appear, where the ship might roll, and where the structure might experience abnormal stress. Many crazy ideas die inside computer models long before they ever reach a shipyard. The 19th century was different. There were no modern computer simulations, no fluid dynamics software. Much engineering knowledge could only be gained through real-world testing. This approach, build it first, then let reality test it, was not limited to shipbuilding. Even in the early 20th century, the development of early aircraft still advanced through repeated real test flights. Before Louis Blériot crossed the English Channel, he built a whole series of experimental aircraft, from the Blériot 1 to the Blériot 11. These machines came in all kinds of shapes. Some were monoplanes, some were biplanes. Some could barely fly at all or crashed after only a few attempts. It was not until the 11th model that he successfully crossed the English Channel. So, trial and error itself is nothing shameful. Early engineering often moved forward exactly this way. What makes the cigar ship so memorable is its futuristic shape and its absurdly high cost. An early aircraft and an ocean-going cigar ship were not even in the same category when it came to the cost of trial and error. Blériot could test his way from Model I to Model 11. But every time the Winans family tested again, it was like pouring cash directly into the sea. The cost of failure was so high that only a railway magnate family like the Winans could afford to keep making the same mistake for so long. But that does not mean the Winans family were completely innocent victims of the age. Their real problem was that they trusted their own engineering instincts too much. In fact, not everyone at the time was dazzled by the cigar ship's futuristic appearance. From its first report in 1858, Scientific American was already quite skeptical of the vessel. It even predicted early on that this cylindrical hull would roll awfully. Later trials proved that this criticism was almost prophetic. But old Winans remained convinced until his death that the cigar ship would eventually succeed. He saw the resistance problem of traditional hulls, but underestimated the advantages they had in stability, space, maintenance, docking, and commercial operation. He thought he was optimizing the shape of a ship. In reality, he was challenging an entire balance that had been filtered through centuries of maritime experience. The cigar ship was eventually dismantled completely, but that does not mean it left nothing behind. Its unique appearance made it almost impossible for later observers not to think of submarines. According to one theory, Jules Verne once saw Winans' cigar ship and carried the impression of that long, slender metal hull into the Nautilus in 20,000 Leagues Under the Seas. This does not prove that the cigar ship was the only source of inspiration, but visually, it truly looked like a submarine that had appeared on the surface ahead of its time. It wanted to become the passenger ship of the future, but it ended up looking like the submarine of the future. The cigar ship never conquered the Atlantic, nor did it change ocean shipping. But does that mean it was a complete failure? From a commercial point of view, of course it failed. Built for 60,000 pounds and sold for 210 pounds, it was failure in its most obvious form. But from the perspective of engineering history, it was not merely a joke. In an extremely expensive way, it taught later generations that a design must face speed, stability, space, maintenance, and real sea conditions all at once. The Winans family did not calculate that answer. They paid for it. And in many ways, that was the fate of many early engineering projects. Even in the 21st century, when early SpaceX rockets exploded again and again, it also looked like money being burned. Of course, SpaceX later turned those failures into experience, while the cigar ship never reached that point. So in your view, what exactly was the cigar ship? A meaningless obsession of the rich, or an expensive but real engineering experiment? Share your thoughts in the comments. This has been a brief history of cigar ships when rich people tried to fight physics. This is BHE, Brief History of Everything.